Okay, all right, so now we're looking at the iodine pentoxide with the carbon monoxide, which produces carbon dioxide, and the pentoxide is reduced by the oxidant, carbon monoxide, to I2, which is iodine as a gas. Now, as you can see from here, the mole ratio is 1 to 5 to 5 to 1. So over here, we've calculated the number of grams per mole from the periodic table. 2 lots of iodine, 5 lots of oxygen gives us a total for 333.8 grams for each mole. Now, the number of moles that we actually have then is the mass, which is 80 grams, which we have, and divide that by the 333.8 grams gives us 0.24 moles. So if we use all of the iodine pentoxide, we will use 0.24 moles if we use every skerrick of it. Now, let's have a look at the carbon monoxide, which is the oxidant. Okay, here we've got 28 grams. So carbon monoxide, we have 12 grams per mole is the carbon, and 16 grams per mole is the oxygen. Don't forget, this is not CO2, this is CO, this is carbon monoxide. Okay, so CO2 would be 44, which is over here. That would be 44 grams for every mole. In fact, we have 28 grams for every mole, which is roughly, by the way, the grams per mole for air. Okay, so this shows that carbon monoxide will mix extremely easily with air. All right, this is one of its major problems that we have in carbon monoxide poisoning. Okay, the fact that it will mix so easily with air, it almost compares gram for gram with air as the number of grams for every mole. Okay, so its density is very, very close to air. Now, so here we have the mass is given us. We're given 28 grams with the molecular mass at 28 grams as well. So we end up with 1 mole. So if we used up all of the CO, we would use up 1 mole. Okay, so then we have what we have over here. So this comes to 1 mole. And over here we've got the iodine, and we can have a look at that and see how many grams per mole that is. At this stage it's of no interest to us. However, we'll come to that. Okay, so now we know that we've got 0.24 moles of iodine pentoxide with a ratio of 1 to 1 with iodine. Okay, and we can see here that therefore we would need to get 0.24 moles of iodine. Okay, that's what we would expect to get. If we had 1 mole of this, carbon monoxide, we would need, if we had 1 mole of that, we would need 0.25 moles. No, 0.20 moles of this, wouldn't we? Okay, so we would not have enough. If we used up this, we would not have enough of this iodine pentoxide. Okay, so if we're using 0.24 moles here, and we have 0.24 moles over here, which is a 1-to-1 ratio, then we can now calculate how much gas we're going to have. So PV equals nRT, so V equals, you notice that I've got here, so 0.24 moles times the R, which is the constant, times 270, well that's 273, that should be 293. That should be 293. Okay? Yep. and divide that by 101.3 kilopascals, and we end up with 5.79 litres. And make sure we have the right amount of sig fixed, we are talking 5.8 litres. Okay? All right. Carry on with the second question, please.